In system design, the cache stampede, or thundering herd, happens when a hot key expires and many concurrent requests all miss and slam the database at once. By the end of this walkthrough, you'll know why a lock alone isn't enough and how to make losers wait and reread the cache instead of querying. We start with an async function that takes a key and returns the data for it. First, we ask the cache for the value that goes with this key. If the cache had something, we return it immediately and skip everything else. On a miss, every request tries to acquire a lock tied to this specific key. Only one request will actually win the lock, and we check that with gotLock. Inside a try block, the winner queries the database for the real value. It then writes that fresh value back into the cache so everyone else can read it. A finally block guarantees the lock is released even if the query throws. With the cache warmed and the lock freed, the winner returns the value. Now for the losers, the requests that did not win the lock. They loop, and on each pass they pause briefly with a short delay. After waiting, they reread the cache to see if the winner has filled it in yet. As soon as the value appears, the loser returns it and exits the loop. Finally, delay is just a small helper that resolves a promise after some milliseconds. Imagine 3 requests for the same key arriving at almost the same instant, all landing on a cold cache. Each of the 3 checks the cache, finds nothing there, and moves past the early return. Now all 3 try to acquire the lock for that key, but the lock only grants ownership to one of them. Say request A wins the lock, so its gotLock is true and it enters the winner branch. Request B and C get false back, skip the winner block entirely, and fall through to the waiting loop. Request A is now the only one talking to the database, running the expensive query just once. As soon as A gets its result, it writes the value into the cache so everyone else can find it. Meanwhile, B and C are asleep, waiting 20 milliseconds before they even try again. The finally block guarantees A releases the lock whether the query succeeded or threw. B wakes up from its delay and rereads the cache, which is now warm thanks to A. It finds the value and returns immediately, and C does exactly the same on its next wake-up. 3 simultaneous misses, 1 database query, and all 3 callers walk away with the same value. Let's talk about what actually goes wrong when this guard is missing or misused. Imagine we deleted the gotLock check and let every request fall straight through to the database query. On a cold cache with 1,000 concurrent requests, all 1,000 miss on line 2, and all 1,000 hit the database at once. That is the stampede, and it can overwhelm the database precisely when traffic is highest. The single most common mistake is treating acquire as a guaranteed success and querying regardless of what it returns. Now notice the finally block, which guarantees the lock is released even if the database query throws. A real gotcha here is that a crashed process can never reach line 12, so your lock needs its own expiry as a safety net. The loser loop is another risk, because if the winner dies before warming the cache, these waiters spin forever. One more subtlety: if the database returns nothing, val stays undefined, and the losers can never satisfy the check on line 21. Get these details right, and one query serves the crowd. Get them wrong, and the guard quietly becomes just another way to hammer your database. A lock only helps if losers actually wait on it. Winner queries the DB, losers poll the warmed cache. Always release the lock in a finally block. If that helped, subscribe for more.